Construction of a cDNA by using a messenger RNA. cDNA means complementary DNA. We synthesize the complementary DNA and by using a messenger RNA as a template. We know the messenger RNA, it is 5' and 3'. 3' and contain a poly A tail. So we know this messenger RNA, one is your 5' and another is your 3'. The 3' and contain your poly A tail, and against this poly A tail we use a DT oligo DT. So AT, we know this is a base pairing, so we use a DT as a primer for providing the direction for synthesis of your cDNA, which is your complementary DNA. So your messenger RNA, which contain your AA poly A tail, and against this we use a DT primer, and DT provided a primer for the synthesis of your cDNA by using the enzyme known as your reverse transcriptase. So oligo DT primer serve as a primer for the synthesis of your cDNA, that is your complementary DNA, with the help of the enzyme known as reverse transcriptase. We know in transcription the DNA is synthesized from the DNA synthesizes the messenger RNA, but hence the name is reverse. So you uses the messenger RNA as a template for synthesis of your DNA. Hence the enzyme is used known as your reverse transcriptase. Now, as the synthesis occur, as a result, now we have used another enzyme or sodium hydroxide alkali to degrade the messenger RNA, as our goal is to synthesize cDNA, not messenger RNA. So we degrade this messenger RNA with the help of an alkali, sodium hydroxide or RNAH, and we use only the cDNA. This is your cDNA contain your T. Now, this single-stranded cDNA form a structure, a hairpin loop structure, and this hairpin loop structure act as a primer. So what happened? We do a sodium hydroxide for degradation of your messenger RNA. Now we contain only your single-stranded cDNA, and this single-stranded DNA form a hairpin loop structure, and this hairpin loop structure act as your primer and for DNA polymerase to synthesize the complementary strands against your single-stranded DNA. So this is the structure and this is your structure. Okay, this strand is synthesized from here and these two strands, but these two strands are still joined together. Then we have to use another enzyme known as S1 nuclease to break this strand. As a S1 nuclease, this enzyme S1 nuclease break this strand, we get a two single-stranded DNA, and this is the synthesis of your complementary DNA from your messenger RNA. Thank you for listening. Ciao, ciao.